congruent segments and congruent angles is what we need for example 6 here. So we probably should define what congruent means. Congruent means that they have the same measure, right? They're not the same thing, but they have the same measure. So if two things are equal, that means they're the same thing. So you can have two lengths. For example, let's say that AB was 5. The length of AB was 5, and the length of CD was 5 as well. We could say that AB, right, equals CD. Because remember, A to B means the distance from A to B, so that would mean 5. It's a number. CD means the distance from C to D, so that's a number. So those things are equal. Okay. Segment AB, though, is not equal to segment CD. Okay, these things are obviously different segments. If they were equal, they'd be in the same location, but they're not in the same location. This one's up here. AB's up here, and segment AB's up here, and segment CD's down here. So they're not in the same location. They're in different locations. Since they're in different locations, they're not equal. But what we are going to use to describe them is we're going to say that they are congruent. They have the same length. So if they have the same length, if AB is equal to CD, we can say that segment AB is congruent to segment CD, meaning they're not equal, right? AB is up here, CD is down here. They're not equal. They're two separate segments, two distinct segments, so not equal, but they are congruent because they have the same length. Okay, in the diagram, we know they have the same length because of these tick marks. All right, so AB has one tick mark here, so it's going to be congruent to anything else. If you have one diagram, anything else with one tick mark is also going to be the same length. So AB and CD are the same length, so their AB is equal to CD. Their lengths are equal, but they themselves are not equal because they're obviously different lines, different segments. So we're going to say they're congruent. And we use the symbol, the equal sign with the tilde over top to say that. So segment AB is congruent to segment CD. Down here, each of these, segment PQ and segment RS, they have two tick marks on them. So we're going to say that PQ, segment PQ, is congruent to segment RS. Okay, for angles, it's the same thing, right, except we're going to use arcs on there instead of ticks. So angle TUV has one arc on it. And then angle XYZ has one arc on it. So we're going to say that those two angles are congruent. And that means that their measures are the same. All right, so segments are congruent because they have the same length. Angles are congruent because they have the same measure. That means the numbers are the same. So again, the measure of angle TUV is equal to the measure of angle XYZ, right? Because those are numbers, right? The measure of angle is our number. So if this was 20 degrees, this is also 20 degrees. Okay, and this measure of represents the number. So the numbers are equal, but these are obviously two different angles. This angle TUV is over here on the left, angle XYZ is over here on the right, so they're not the same. They're not equal, but they're congruent because their measures are equal. Right, the measure of the angle is the number, and those can be equal, but the angles themselves are obviously two different angles, so they can't possibly be equal. So we say they're congruent. Down here you have two arcs. Okay, so that tells us that those two angles are congruent. FGH is congruent to JKL. This might be 80 degrees. And if that's 80 degrees, this one is also going to be 80 degrees because their measures are equal. Okay. They give you a little bit more information here, but we don't want to make the video too long, so we're going to skip over that for now, and let's get on to example 6. Which is right here. So before this loads, if we look at the diagram, we see we have two congruent angles. We see that angle X, WY is congruent to, it's got one arc, so it's congruent to any other angle with one arc, and the other angle with one arc is this one over here. So it's congruent to angle ZWV. So we know that this one is also 32. So this angle here is 32, that angle there is also 32, because those angles are congruent. The arc tells us that they're congruent, which means they have the same measure. So if the measure of this angle is 32, then the measure of this one is also 32. Okay. So let's just write that out then too. So since they're congruent, we know the measure of angle XWY is equal to the measure of angle ZWV. So we know that they're both going to be 32 because they tell us this one is 32. Okay, so we have 32 and 32. So in our problem here, it says the measure of angle XWZ is 127. So that's the big angle. So let's do that in blue. That's this big angle here. All right, XWZ. The measure of that angle, that whole angle here, is 127. And then we want to find the measure of angle YWV. So let's do that in yellow here. Or actually, let's do purple. Okay, so YWV, that's this one here. I'm going to put an X there. Okay, so we have three angles here. If we add them all together, they should add up to 127. So 32 plus X plus 32. And if we add all those together, 32X and 32, we should get the whole thing. And we know the whole thing is 127. Right? So it tells us the whole thing is 127. We want to find this inside angle, YWV. We have this is 32. This is congruent to this one. So we know it's also 32. So 32 plus X plus 32. Add those together to 127. So that's 64 plus X. Subtract 64 from both sides. I'm sorry, 127, getting ahead of myself. Subtract 64 from both sides. And we're going to get X equals, what is that, 63 degrees? And then we can check our answer and make sure we did it right. 63 degrees, right? Measure of XWI plus the measure of WYV plus the measure of VWZ is going to equal the whole thing, the measure of XWZ. All right? And now you guys can do the try it. There's 3 try-its on this one.